So the plan today is to discuss the Lambda function, right, which is one of the most commonly used service in AWS platform offering, right? And this is coming under the category of serverless. So serverless, as I explained yesterday, customer don't have servers to manage. This is like a kind of, for example, if the business wants to execute something for their business function, they can use this Lambda function. It is more of a function as a service, which comes under platform as a service category. Okay, so Lambda function is coming under the platform as a service category, and within that, this we can call it as platform function as a service category, right? Function as a service or platform as a service. So function as a service, container as a service, database as a service, all these comes under the same category, which is platform as a service category. So here, if business want to do some activity or do some scheduled task or do some routine activities, they can use this Lambda function. But Lambda function is not suitable for all the use cases because it has got some limitation in terms of the amount of resources that we can use in terms of memory or in terms of the number of resources handling the duration of the function that can run. Okay, so there are some limitations, so we need to understand those limitations and decide what is best offering, maybe like whether we need to go and use EC2 instance or ECS container or Lambda function based on the customer use case or scenario, right? So AWS Lambda function, again, it comes under the compute service category only. So this is a compute service, and this is mainly a kind of event-based trigger. When I say event-based trigger, so whenever there is some event that is happening, so if someone is uploading a file to an S3 bucket, or if there is a new event coming in a log file, or some server or some log is coming in to a storage or to a file. So all these are kind of examples of event, right? There are hundreds of examples of what kind of events that we could use as a base or trigger to do an activity. So what I mean, at a very high level, see, let's assume this. Okay, so there is a new S3 file that is getting uploaded. Maybe after this file one is uploaded into the S3 bucket, maybe the business want to uh, do some changes. Maybe this file one, they want to convert it as a compressed file or a zip file and then put it into another location, or they might also want to change the format of the file, like maybe from JPEG to PDF, or maybe they want to create a thumbnail out of this file, or they want to convert the extension, something like that, right? So all these are kind of business requirement where they want to change the file format or take some content within that file and then put it into a different location. Maybe there is a set of records that are adding up in an Excel file or a text file, and they want to pick up some specific fields and then take that to a different application or whatever. These are all some use cases where business have to do something on a particular new file that is getting added. So these are all some sample examples, right? So we can use Lambda function for converting the file to a different format, or creating a zip file out of it, or creating a thumbnail out of it. So this Lambda function can automatically do when there is a new file coming in, or when there is an event that is happening on a particular scenario, right? So this is what we call it as event-based trigger. When a new file comes to S3 bucket, this can be converted to a different format, or this can be compressed, or this can be, we can create a thumbnail out of it, or we can fetch for some specific fields or information in that file and then take it to a different application. So these are the different business function we might have in this particular example. Similarly, if there is a new log that is coming in, that a particular server is experiencing performance issues, or some downtime, or some service has stopped, we can also use Lambda function to go and automate the startup of the services, or maybe restart the server, or try to apply some fix, or add some tools if there is someone is uninstalling a particular agent on a particular system. So if the Lambda function gets to know that the agent got uninstalled or the agent got stopped, it can go and automatically fix that agent by upgrading it or reinstalling it or checking the log files and taking all the necessary action. So you can do automation. So this particular Lambda function, it is not only used by developers. Developers are also using it for their serverless architecture design. So wherever they can use Lambda function, they are using it in their serverless architecture, and even the DevOps teams are also using it for doing all the CI/CD automation, and even the operations team, the cloud operations team, can also do perform automation using Lambda function. So the advantage of using Lambda function is that the Lambda function supports almost all the popular programming languages. So if you are good in Python or JavaScript or different programming language, almost all the popular languages are supported in the Lambda function. Okay, supports all popular, mostly used programming languages. So if you want to create a Python code, or if you want to automate something using a different programming language, you can go and write your code, and this Lambda function is going to help you do that. So the very first important point is run the code without thinking about the server. So that is what we primarily calling it as serverless. So serverless is the base concept which customer want to experience. When we say serverless, the customer don't have to do the operating system maintenance, the capacity provisioning, the automatic scaling, the patching, security patching, and all those things, right? So that is all automatically covered as part of it. So indirectly, when we are talking about serverless, I'm not sure if I gave all some points yesterday. Okay, so I'm talking about the OS maintenance activities will be taken care by AWS, and then the capacity that we need will be provisioned automatically based on the need, and automatic scaling of resources also will happen behind the scene, and the code scans, the security checks, and then the security patches on the operating system level or the infrastructure level. All these are taken care by AWS, and even if there is some code changes, or if you want to get some logs out of it, all this monitoring and logging are also provided as a service. As a customer, we just have to create the application or the automation code, and Lambda function can take care of all the backend infrastructure related stuffs, plus the high availability is also inbuilt. So Lambda function also has a HA infrastructure behind the scene. It is not going to get impacted if one server goes down or if one data center goes down. Your Lambda function will still continue to function, because Lambda function by design, it's a highly available compute infrastructure. So whenever you go and run a code, that code is going to get stored in multiple availability zone. So if one server goes down or one data center goes down, your activities are not going to get impacted. So the backend administration, the load balancing, the high availability of the Lambda function is taken care by AWS itself. So it's a highly available infrastructure. So that means you don't have to really worry about the high availability and the SLA portion. So AWS is going to guarantee you with the SLA on the infrastructure level. So there is not, I mean, the downtime will not be there. So we don't have to manage the server, number one, and we don't have to worry about the high availability of the infrastructure. And indirectly, when we say serverless and high available infrastructure, these benefits are coming to us because AWS is giving all these options as an offering. So they are managing it and maintaining all these stuffs on the fly, right? So we get all these benefit. Plus, automatic scaling is something which we have to call out clearly, because automatically the whenever there is an increase in load, for example, there are 10 users and it changes to 100 users. So based on the automatically increases the resources based on the load. So if there are more executions, more number of users accessing it, and based on the scale, based on the code execution request, automatically there will be a response, and response based on the number of calls, events, and then uh, and so on, right? So based on that, automatically the resources that we need can increase. There is a limit. I will come to that configuration part. So it starts with minimum 128 GB of memory, and it can go up to 10 GB of memory for your memory. And even if you want to have some temporary ephemeral storage, even the same is applicable. You can get up to 10 GB of space for storing any ephemeral contents, temporary contents there. And again, the pricing is also very straightforward. It is pay as you go pricing model. As per consumption, we are going to pay for it, right? Based on the number of times the execution is happening, you are going to pay by the millisecond of execution. So if the Lambda function is running for 1 second or 2 second or 100 millisecond, so you are just going to pay for the amount of time the Lambda function is running and amount of resources the Lambda function is consuming. So amount of resources maybe like let's say 256 MB of memory or 256 GB of memory, like whatever based on the consumption, we are going to pay for it. See, we are not provisioning anything. So instead of provisioning the resources upfront, Lambda function will consume what it needs, and we have to just pay for the peak capacity, pay for the usage. Okay, so if you are provisioning it upfront, we are paying for the peak capacity, right? For example, if you talk about in EC2 instance, if you are just giving 256 GB of memory to that EC2 instance, we use it or not use it, we are paying for it. But here it is not the case. So here, if you are using only 100 GB, or let's say like not 100 GB, like let's say if you are using 100 MB or 200 MB, we will be only paying for that 200 MB of usage. So if you are using 1 GB, we will be paying only for that 1 GB of usage, unlike the EC2 instance. In EC2 instance, we are going to provision whatever like 2 GB or 4 GB upfront. We use it or not use it, we have to pay for that maximum size that we have, the peak capacity that we have provisioned. Like whatever the 4 GB, if you have given it to the server, 4 GB we have to pay month on month. But for Lambda function, it is not like that. So if you are using only 200 MB of memory, and we have to just pay for 200 MB of memory, and based on the number of requests and consumption, we are going to pay for the consumption only at the utilization level. One more thing, like we get a lot of free
So
requests
even
also. Yeah, 1 million requests free per month.
even
Yeah, go ahead.
even if we reserve higher resources stand,
Yeah,
we still have to pay whatever we use, right?
come again.
Even if we reserve higher resources, like
Hmm.
higher resources, and we use only a small fraction of it, so we are
No,
paying just for those amount of
okay. Hmm.
you know the
No,
usage
it's
part, right?
yeah, it's only see, we are not going to reserve anything there. Let me show you this. So test one. Just I'm creating for testing. Okay, so let it create. It should create in a minute. Okay, I'll explain it. And also the performance also we will get optimized performance because it is auto scaling is there automatically. It will optimize the execution of the code based on its requirement, the time and resources, and then whatever the memory based on the demand, it will provision the concurrency and all those stuff. So let me scroll down. So here, if you go to the configuration, right? So you can see that the minimum we are giving it as 128 MB, right? So obviously we have to pay for this minimum size. But after this, you can go up to 10 GB of space or whatever. But you can just say like I need up to 10 GB, but the actual billing will be happening only for the actual consumption that you are going to have. Like maybe let's say like you are only consuming 500 MB of capacity for the Lambda execution, you will not pay for 10 GB. Instead, you will only pay for 500 MB capacity only. And same goes for the ephemeral temporary storage, the temp drive where you store all the temporary content. You can go up to 10 GB. This is the maximum limit. Okay, if your application needs more than 10 GB or more than 10 GB temporary space, you have to go for EC2 instance or container services based on the application nature. So there is some limitation in terms of the configuration and the time. See, even you can run maximum of 15 minutes only. So if your job is going to take more than 15 minutes of time to complete the task, then Lambda function is not the right uh, choice. You're getting my point, right? So there are some limitations in terms of memory,
Yeah,
efficient
so that's
storage.
more
Yeah, yeah,
clear. Thank you.
yeah, yeah.
Sam.
Storage timeout max 15, 10 minutes, 10 GB, 10 GB. If your requirements are, if the customer requirements are beyond this, then yeah, we have to go for it. And even if sometimes we might need specific OS version or specific platform version. When I say platform, I'm talking about the programming languages and the underlying runtime environment. So here, the runtime environment, we generally get the latest one, n minus one, n minus two, right? So that is what we saw here. For example, when we are creating a function, so we'll see the versions here. So you will not see a lot of older versions, but you will see some versions. For example, starting from 3.8, it is there. And similarly, you have support for Ruby version 3.2 and 3.3. So there are some cases n minus 1, in some cases n minus 1 and n minus 2. When I say n, the latest version, minus 1, minus 2, and so on. So there are only selective versions that are available, but there is a wide range of runtime environment that are available. Okay, so most of the popular runtime environments are there, but the versions are limited. That's what I'm talking about, the runtime version limitation. Okay. So that is not the only thing, but we have more support there. Even there is a lot of blueprint that is available. So when I say blueprint, see, these are the common use cases. If you go to customer environment, like let's say when we want to get some metadata out of the S3 bucket, or if someone uploads a new file, or if someone modifies the HTTP response header, what kind of output we have to go, whether we want to do a batch job, whether we want to submit some new batch job. These are the commonly used use cases. So for all of these, AWS has given the configuration code, sample code, and the preset options available for most of the customer use cases. And as an operations engineer, mostly we will do these things, like we will send the logs to a Splunk environment. We will schedule a specific periodic check of a URL to ensure that the URL is accessible. We will also check some send some CloudWatch to Sumo Logic or Splunk environment. So whatever, these are the common automation use cases for IT team, and even there are some application specific case studies. So these are the common use cases that we have. So outside of this, there are some more use cases which you can find it in AWS GitHub and even in AWS case studies and blogs. I will also show you some samples and demos on how you can implement specific case studies. There are 100 plus templates that are available for many of the customer environment, maybe 60 to 70%. You might find an existing sample code to start with and slightly modify it to reflect the resource names. For example, the S3 bucket name or the SNS topic name, the CloudWatch log group. So whatever based on your organization standard, you can just update only those specific fields and areas. So there are a lot of existing blueprint templates or presets that are available. So blueprints, templates, preset configurations are already available for many customer use cases and IT automation requirements. Okay, so coming to the next point, let me also check here if I have something. So serverless, this is one of the commonly used service under compute. There are many serverless products available from AWS under different category. If you want to integrate two different applications, they provide you simple queuing service. Similarly, if they want to send some notification, they have got simple notification service. So these are all very commonly used. So AWS Lambda is commonly used with SNS, and it is also commonly used with CloudWatch. I will show you some sample demo, so that way you understand all these link. Okay, so customer will develop a architecture which involves serverless architecture, they will say. So which means they have used Lambda function, API gateway, DynamoDB, S3 bucket. So all these services, we don't need the customer to manage the server. AWS manages the server infrastructure, virtualization infrastructure, plus the operating system on the behalf of customer. So we don't have to worry about the server. We just have to run the code, and whatever the business application needs to function, the individual functions will be invoked, and it will scale automatically, and it will run. So when customers, when the architects are developing a solution using serverless architecture, they are talking about these services. They are not using EC2 instances or other infrastructure as a service component. They are primarily using all the solution like platform as a service offering products and services, where servers are managed by AWS themselves. Right. Coming to the benefits of AWS Lambda. Okay, so Lambda runs your code without provisioning. That is fine, and so it is going to run in on a based on the event. So you pay for this, and yeah, this is something which I've already mentioned. So we can write the code on whatever language that we are familiar with, right? And then you pay for only the consumption time. Okay, so this is the limitation, right? So it can run for only a specific duration, and it will have only specific resource sizing, right? So it has got limitation by sizing, and it has also got limitation by the amount of time the executions can happen. So there is one more interesting point here, right? There is something called snap start, which is immediate start. See, when you are talking about EC2 instances, there is a time whether the operating system has to come online, and there is a lot of delay, and the execution will take some time. So here, AWS provides you a quick snapshot based snapshot, where there is no delay at all. So if you want to run the Lambda function immediately, it will run immediately because it is already configured and ready to run here. So if I go to the snapshot option here, so this is what I'm talking about. So Lambda will be cached on the AWS platform level, and there will be a snapshot that will be there, and that snapshot image will immediately start triggered, and it will run. There is no delay at all. Okay, that's what they call it as snapshot, which is available as a feature within Lambda function. Immediate start using the snapshot functionality. That's what we call it as snap start. So generally, we create the role based on the requirement. For example, let's say if my IAM role needs to access some S3 uh, S3 bucket, or if it wants to store some logs in CloudWatch, or if it wants to send some notification to SNS topic. So we have to create a IAM role in IAM console, and then use it for the particular execution, right? So if you go to IAM, so we have seen this IAM role earlier, but I'll just quickly show you what we generally do. So you go and create IAM role, select the AWS service, and common use cases, we go and select Lambda. And from here, you have to go and select the specific service which it is going to consume. For example, if it has to access S3, you have to provide access through S3. Whether it needs only read access, you can just provide read access, or if it needs full access, you can provide full access. Similarly, if it wants to send some notification to SNS, you can just send SNS role, or you can give full access based on the customer requirement. So IAM role is very much important for providing the Lambda function access to different AWS services. On the other side, Lambda function has got integration to almost all the AWS services, I would say. Almost all the services, AWS, I mean, Lambda has integration. Lambda has integration with almost all the AWS popular services, and even on the third-party services also, you can integrate with Splunk or ServiceNow or Remedy or whatever, right? There are third-party services also to some extent. If you go to the AWS console here, let me show what are the examples we have. So if you go to the integration trigger, so this is what we call it as event-based trigger, right? If something happens on an S3 bucket, someone is uploading a file or putting a file, you can just go and search for it like S3, And then if someone is uploading or if someone is doing some activity, they are copying some data to a S3 bucket, or someone is deleting a lot of files, or if you want to move, if some content has moved from S3 bucket to Glacier archiving. So all these are separate event or task. You can just say if someone tries to upload a file or post a file, that event can trigger some backend activity on S3 side, as I told you. So this is some example here. So there are many different services which can be integrated. So you can integrate with AWS native services like CloudFront or API Gateway or S3 bucket, and even you can also integrate with partner services. For example, if someone some new Atlassian ticket is created, or if something has been created in Jira story, or if some Datadog event has happened. So there is a lot of integration with all commonly used tool. If there is a new event on application monitoring, New Relic or Dynatrace, or if someone has logged into a particular Okta login using multi-factor authentication. So there are a lot of integration. So you don't have to really write a separate API or whatsoever. It's like already readily available to get integrated with different services. So it has got a lot of integration. And what is that? So high availability is already mentioned. Just give me a second. Let me take some water. Sorry, I've been speaking from morning, so throat went bad. Okay, so here there are many benefits, right? So it is program language friendly. You can use whatever programming language which you are familiar with, and you can run the code on demand whenever you want to run it, and automatically the backend scaling of the resources will be taken care by Lambda function. As a customer, we can run the code without thinking about the servers or clustering or high availability and so on. At the end, we are only charged only for the compute time and the resources we are consuming on the Lambda function level. So all these are benefits, right? Whatever I have listed here are quite an important benefit. But for the interview, these are the four important benefits that you have to highlight. Serverless, no server management for the customer, automatic scaling, which is flexible scaling, and pay for the value. You are only paying for the usage, the throughput that you are consuming, the runtime duration for which you are going to pay for it, and automatically you are getting the high availability, and the fault tolerance is applicable for multi availability zone. Even if one server or one availability zone goes down, one data center goes down, your Lambda functions will still continue to function as before. There is no delay. See, there are some lot of use cases. That's what I'm saying, right? Someone is taking a picture and uploading it into a S3 bucket. That is a event based trigger. So someone is uploading the photograph to S3. That is the event, and based on that event, Lambda function will get triggered. Okay, and then maybe like after the file is uploaded, this photograph has to get converted into different file format. Maybe some customers are using their application to be accessible from web application, mobile application, and tablets. So they want to create three different file format and then upload it into different folders, and so that if they access it from mobile application or web application or tablet, the resolution and the sizing will be matching to the type of application they are using it. So we can use the Lambda function for similar stuff, like when there is an event that is happening, someone is deleting some file, or someone some new logs have come, or some server has sent an alert to a particular logging tool, or so some Dynatrace event has been identified at the application performance level. So whenever there is an event, this Lambda function could be triggered. That's a high level nutshell, right? So there are many use cases, and these are some limitations which I've already talked about. But when it comes to use cases, so you can use it as a interactive to run as a interactive web and mobile backend application. So you can combine Lambda with other AWS services for any kind of secure, scalable, and stable online thing. And even a lot of customers are nowadays using it for their machine learning, data pipeline, and all those things, right? So it's not that it is only used for a regular application. Even if there is a customer who want to do some extract, transform, and load of their data, like the data pipeline, we call it as, right? They want to extract the data and then transform it to a different tool and then load it. We can also use the Lambda function to do all those things. Even the Lambda function can be used for many machine learning insights or machine learning processing, where if you want to do some processing of the data before feeding into some kind of other environment, like accessing the file from Elastic file system or a shared file system, and if we want to pre-process the data before it goes to a particular system, you can also use Lambda function for all pre-processing or some kind of before feeding to machine learning model. We can use Lambda function to get that data processed. So maybe I would say before feeding for machine learning insight, the data can be processed using a Lambda function. And even the very, very common use case is event driven application. So when there is an event that is happening, okay, and based on that event, the Lambda function can go and do a lot of changes, like it can automatically restart the server, or it can try to change the application code, or it can try to go and make some changes based on the automation activity that we have given. Right, these are the most common stuff that we generally come across. Let me see what we have. If I missed something. Um, okay, so it's not that we have to utilize AWS code all the time. You can also use your own code. Okay, so when you go and create the function, you have the option to go and author it from the scratch. So you can bring your own code, or you also have option to run your Lambda function as a container also. Okay, option to run as a container is also available. So you need not run it on a server. If your code can run as a container workload, it can also be used. So if you, when sometimes you might also want to connect to external storage, that option is also available. If you want to connect to some EFS file system, or if you want to put some files on the shared file system, that is also supported. Okay, let me show you that. So you can also connect to RDS databases, that is also available. So you can connect to database, you can also connect to EFS file system. If you want to store some content on NFS, network file system, right? So you can also associate and store some data there. Those options are also available. Earlier, these were not there, but recent times they have also added it. Let me just highlight it. Integration with file system to store the data after processing. I'm talking about the Elastic file system, the network file system, right? The Elastic network file system, Elastic file system. And then you can also have integration with, this is post execution, right? If you want to store some data in a particular database, or if you want to store it in a file system format, it has got that integration readily available. So we don't have to write any API or do anything specifically. And if you want to do this execution within a particular VPC network in customer environment, if you don't want to run it on AWS common network, you can also go and specify which network we need to use, and if there is some IP that needs to be um, utilized, we can also run it in a separate dedicated network. So customers activity will happen within the customer network infrastructure. And if you want to specifically invoke some URL, or if you want to give some concurrency for your activities, like sometimes like your application might have to run in loop, or sometimes it might have to run parallelly for some of the workload to quickly complete it. So those concurrency can be enabled. So that option is also here This is not for all the use cases. For some of the use cases, we might have to reduce the duration of the execution. Some customers will say it is taking more time compared to the on-premises, some batch jobs or some scheduled activity. You can go and enable concurrency to get parallel resources, parallel memory or temporary space. So that way the concurrency will get enhanced, right? So those are all very important options which we might use. And as a developer will also use one more option called layers. Okay, so layers is mainly for adding some additional packages and additional stuffs to run your code. Here it is, right? Okay, so the layers are nothing but if AWS also provides you a lot of common layers that are available, so you can assume that as a kind of pre requisite. Like if you are going and installing some application, so it might ask for Java runtime or .NET framework, some specific version, something, right? So if your Lambda function has dependency on a particular runtime or a particular architecture or a particular instruction set, you can also go and choose that. There are many different prerequisites that are available for some of the executions. If your Lambda function needs TypeScript, or if it needs some specific credentials or something that is stored on the secret manager, you can also add that layer so that the authentication or the specific layer you want, you can use it. You can also go and create your own layer. The developers will create the prerequisite layer for running your Lambda function. So it is case to case. So layers are also used by the developers, but we just need to be aware why that layer are added for that particular Lambda function. Maybe they might have added it for application level authentication, or they might have stored some secrets on maybe in the key management service or the AWS parameter store where the credentials are stored. Maybe there are some packages that are needed in order for the execution to happen. So those prerequisites can also be added as a layer, so that way we can execute the Lambda function. There are two ways of doing it. One, if it can automatically download it, let's say, like if while I'm creating a Lambda function or within that Lambda function, so there is an option to import it. Not all the prerequisite can be imported. See, let's say if I want to import a functionality within my Lambda function, if I want to have the capability of reading a particular comma separated value file. Okay, I can just say import that CSV. Similarly, if I want to use Boto3 for my Python script, I can also import it. There are certain modules that are that can be automatically imported, but not all the modules can be imported. So there are specific modules. I can just get you that list of modules supported in AWS Lambda. So if the developer sees that particular Lambda function module is not available, then only they will go and add it as a layer. Otherwise, they will be able to handle it within the readily available. The AWS has got a backend repository or artifactory where they can go and import those list of options here. See, these are the complete list that are available. So developer will check this list. If they don't see that specific module, then only they will go and create an additional layer and get it added. Otherwise, most of the readily available packages are there. If they want to read some CSV file or text file or whatever, those modules can be directly added. It will import as part of the execution. So all these modules that are getting imported, they will be getting stored on the ephemeral storage. So if you are running short of ephemeral storage or memory capacity, then you can go and troubleshoot it, add more capacity, and that way there won't be any challenges. So you can see, compared to let me also see, there was one latest improvement that AWS has got. See, AWS has got their own processor, okay, called AWS Graviton processor. I was there. Okay, Graviton option. So there are some Lambda function option where you can run it on Graviton processors. Okay, so there is a way to do that. So if you are running your Lambda function using this Graviton processor, you will get better cost benefit, and you will also get more performance. Okay, we migrated some of the Lambda function from existing processors to AWS Graviton processor. So while we are creating it, So you saw that option, right? I'm not sure if you paid attention to that. So while you're creating it, you get a couple of options to choose the processor type. So if you are running it on Graviton processors, you will get lesser cost and lesser price also. So that is what they are talking about here. So in some customer environment, we also got some cost optimization as well as better performance, right, by migrating from x86 to AWS Graviton 2 processor, which is powered on ARM processors, ARM processor. But you have to validate it. You have to test your function, Lambda function. Not all the Lambda function might run on it. Even for some customers, like some of the functions were executed. Some functions we had issues. So those are all still running on the x86 platform. So you can see the use cases. Many customers have already migrated to the AWS native Graviton version 2 processes, where they have got a lot of better performance, plus the cost has also reduced, and also the runtime, the request handling is also more efficient. So these are all something which you can do as a customer. You can also migrate it, you can also change it, but before changing it to the production environment, obviously, like, you have to follow the change practice and do it in the ITG or non-production environment, then go to the Graviton processor. That is another thing which you can keep in mind. So migration to uh, ARM processor, which is AWS Graviton version 2 processor, that will give you cost benefits and performance enhancements also for your application. With the same capacity, you will get 20% better performance and 30% 30% better performance and 20% lower cost in that. So all the monitoring, logging, observability, everything is up to the mark. So you don't have to really reinvent anything there. So if you want to monitor things, if you want to log the activities, if you want to observe some specific metrics or monitor some specific activities, all those capabilities are inbuilt. So monitoring is integrated with CloudWatch, and log, you have the cloud trail, and you can also integrate with third party Splunk or Datadog, whatever, right? So whichever is your standard, you can go and integrate it with it. And even you can use Datadog or Dynatrace or whatever X-ray for getting more application metrics. Just one second. Integration with APM and APM tools. So APM is application performance monitoring tool, like Datadog, Dynatrace, and all those things. And IPM is like your whatever third-party infrastructure performance monitoring tools. There are many, right? SolarWinds is there, and there are many such tools. But yeah, native itself is sufficient, like the X-ray and those options. But in some cases, if customer has specific requirement for their programming language or their specific application requirement, then they can go and monitor those functions using third-party application performance monitoring tool. So you don't have to really worry about the security portions. There is a integrated security model where all the best practices, security standards, the compliance needs are already met. So most of the industry vertical have approved using the Lambda function. So it has all the legal, security, and the compliance standards met. So Lambda function is pretty much in line with that. Oh, what else I can cover here? I think mostly I've touched upon all the important key points. Let me see. Any questions so far on the use cases, benefits, overall, like what exactly Lambda function is? Because this is very, very important. Most of the customers are using Lambda function. Almost all the customers are using Lambda function because it has got zero administration at the server level, infrastructure OS level. So it is completely serverless. So that's the reason customer want to utilize this option as much as possible. And if you're running your active business functions, business activities, business tasks using Lambda function, definitely there is a lot of cost reduction. You will pay way less compared to your EC2 instance or your on-premises methodology. So as I told, EC2 instance provides you a lot of flexibility, a lot of wide range of option to choose the instance type for specific workload, specific network requirement, specific software stack, or specific security requirement. EC2 instance provides you a lot of flexibility, scalability, and a lot of wide range of options. AWS Lambda has limitations in terms of the type of resources you are choosing from. For example, if you want some specific GPU or graphics processing or some high-end stuff, then obviously EC2 is the right choice. If your application is containerized, then yeah, EKS or ECS is also a better choice. But Lambda function can help you to execute code or execute task in response to a particular event. It can be integrated with DynamoDB table or any custom event that you are creating with your application. So Lambda function can be integrated and can be useful for many use cases, but not all the use cases, right? There is no one product fitting all the requirements. So here, AWS Lambda meets a lot of customer activities, customer use cases. You can pretty much use it. So I'm just waiting for any questions from your side so that. So AWS takes care of applying all the security patches, routine maintenance, and health checks, and all those things are taken care by them. So infrastructure level, OS level, you don't have to worry about it. AWS Lambda team takes care of it. Okay, so some people maybe if you're still not clear, the Lambda function means the code that you're writing, right? That is what we call it as function here. That is the business function. So the code is going to perform the business function on our behalf. So Lambda function has got it's nothing but a automation code, or it's a function code behind the scene.
I would say that no, this will automate. Uh, I mean, I can use this for an automation. Like I
Yeah,
want to
yeah,
do
IT automation. Yes,
uh,
yes, yeah,
restart of a server,
yeah.
or shutdown of a
Mm-hmm,
server on a daily basis.
mm-hmm, mm-hmm.
Maybe making a hibernate of all the VMs after 6 p.m. All these can be doable using this function.
Yeah,
Is it
IT
correct?
operation
Something?
tasks can also be automated. Yes.
Okay.
Yeah.
But okay, is that the only way I can do, or I can do it
No, there are many other ways.
even
So
in
there
the
are a lot of
okay?
playbook options that are available. So you can also use automation. I
Uh-huh.
mean, Lambda function as a playbook or a run book. But see, there are a lot of
Uh-huh.
playbooks that you can write with through
Okay.
Ansible or even through Systems Manager. There are some many tools available, and this is not the only way. Okay, so you can also use CloudWatch Event Bridge, or sorry, CloudWatch event to do the activity that you mentioned. For example, if you want to perform some specific activity at a particular time to bring the server to hibernation or to restart the server, there are other ways of doing that also, and that is more straightforward. Think rule or task. Your audio is very low. Maybe your mic is misplaced.
Hello.
Ah, yes, Santosh.
I
Yeah,
Hi.
yeah, yeah.
Can we do one demo
Yeah, yeah, I'm
while
going to give you
creating one
some sample
EC2
demos. Yes, yes, for sure. Like we can
means
have. I'll show you like how to integrate with S3, how to integrate with API Gateway, and so on. See, since we have not seen that tool yet, I have not shown it yet, but we are going to see some sample use cases on how to integrate with DynamoDB, S3, RDS, and all those things. Don't worry. But for now, like at a high
Okay.
level, maybe like compared to yesterday, today, where we might exactly use Lambda function, right? At a very high level, the use cases, the benefits, and so on.
If unknown customer is there, how can we give the advantage? Means how can we explain with
Hmm.
Lambda on the AWS front? If a customer not aware, because as
Uh-huh.
we are in the IT industry,
Uh-huh.
we having a different projects.
Hmm.
If a project manager not aware of the Lambda futures,
Hmm.
because depend upon the, is there is any flow chart which we
Hmm.
need to present to them like that?
Uh-huh.
Is a
Okay. Hmm.
AWS will means explain to the some other means some project point of view, new
Good
project.
question.
Okay.
Good question, Santosh. Okay, so what I will do is I will help you on how to how to do a decision making. I understand your question.
Mm,
See, decision making has to be explained in multiple ways, right? So we have to say,
mm,
we have to show them whether those features and functionalities are available on the tool that we are trying to promote, right? Maybe in this case, Lambda function against EC2 or other services, whether those options are there, and what is the cost benefit that we are going to get on using AWS Lambda against EC2, and what are the performance benefit and the other relevant things, and whether we have that security, legal, compliance requirement met with this particular tool, because we are running it on a server which is managed and maintained by AWS, not the service provider here, like not
okay.
the direct
Mm,
service provider. We are directly going to AWS for running it. So some customers might have those questions also. We have to explain from that perspective. Then obviously other areas, the operational stuff, right? Whether we have the monitoring, backup, HA, security, and not security, the observability and all those things, logs to troubleshoot. So all these things will be asked. So I will give you guidance on these 5 areas on how to do a decision making, when to choose EC2, when to choose Lambda. I'll create a flow chart and I will explain it so that we will understand it.
is this his interview question also? These things can ask in the
See,
interview also.
See, if you're appearing for a
On
solution architect interview, then obviously I tend to speak on these 5 areas, right? See, because that is the five
uh,
different combination that will help you to explain a particular product on different dimension, right? See, any product that
okay.
they ask, you can take the approach towards these 5 points, and you will be able to cover end to end. And obviously there will be
Okay.
limitation with every single product, right? And at the end we have to talk about some basic limitations or disadvantages or demerits of using it. So that is something, yeah, I'm also covering at a very high level here. Also I gave some limitations or disadvantages, some few points here, right? So yeah, that is how it is. Yeah. So
Okay.
I'll explain,
Thank you.
don't worry. So we will see some demo. I will also come up with the decision matrix. So I'm